Hello everyone, and welcome to our introductory session on teaching with three-dimensional design using Tinkercad. You should already have a copy of the slides, but if you don't, please pause the video so that you can scan the QR code or enter the bit.ly link on your screen. There are lots of links and resources embedded in the slides, so I would recommend that you make a copy so that you can explore these during or after the session. Today we will be focusing on Tinkercad as a 3D design space. So during the session, I will be switching back and forth between the slides and the Tinkercad website, depending on what is easiest to demonstrate. Before we get started, I would like to take a moment to introduce myself. Hello, my name is Jennifer Robb, and I'm currently a research associate in the STEAM 3D Maker Lab at Ontario Tech University's Faculty of Education. I've recently completed a Master of Arts degree, and the focus of my research was on students from the ages of 7 to 13 designing and making with Internet of Things technologies with the goal of creating social change. I am also a certified teacher in the Canadian province of Ontario, qualified for primary and junior divisions or from kindergarten through grade 6. If you'd like to get in contact with me after today's session, some of my contact information is linked here in the slide for Twitter, Discord, and Mastodon. At the end of the presentation, I'll also have my email address and LinkedIn profile listed as alternative contacts. As I mentioned, I am part of the STEAM 3D Maker Lab team, and the incredible people pictured on this slide will be providing you with sessions on many different topics. On the map here, you can see approximately where we're located, just north of Lake Ontario in the Durham region. Our lab and the Faculty of Education are both located in Charles Hall, part of Ontario Tech's downtown campus in Oshawa, Ontario. If you'd like to take a virtual tour of Charles Hall, you can click on the linked text in the slide here, and it will take you on a 360-degree tour through the gorgeous building. So here is the agenda for today's session. First, I'm going to go through an introduction to 3D printing and Tinkercad. After that, we'll get into making an account and exploring the Tinkercad website, and then we'll set aside some time for an activity where you'll go through some of Tinkercad's step-by-step tutorials. Once you've picked up the basic controls, we will look at creating our own designs in Tinkercad, where again, you'll have an activity to create your own design and submit some reflection on your experience with the tool. Finally, I'll go through some of the extra features that Tinkercad includes to support teaching, and then at the end there's a section of extra resources and activities that you can explore on your own time, or if you have extra time today. Before we move on, I'd like for you to take a couple of minutes just to think about what you already know about Tinkercad or about 3D printing. If your answer is absolutely nothing, that is okay. In fact, that's more than okay, because that means that you'll have a lot to gain from today's session. But pause this video and either scan the QR code with your phone or open a new browser tab and head over to the link here in the slides and make a post with what you already know about these things. Your posts will be anonymous unless you are logged into Padlet, so don't be shy. I'll give you a moment to pause now. Okay, hopefully that's got you thinking a little bit about 3D design and printing. And again, if you're coming to this session knowing very little or nothing at all, that is completely okay, as we'll be starting from a very low floor. Here are some learning objectives for today's session. Hopefully, by the time we're done here today, you will have developed an understanding of some of the basic functions in Tinkercad, such as creating, moving, rotating, and scaling objects, grouping objects to create new shapes, and navigating the shapes library. You'll have created, or at least started to create, at least one unique personal design using those basic functions. You'll have reflected on some possible applications of Tinkercad to teach STEAM subjects, and you'll have reflected on some of the potential benefits and challenges of using Tinkercad as a tool for teaching. Let's get started with our first section, an introduction to 3D printing and Tinkercad. So in this session, we are going to be looking at Tinkercad, which has added new features in recent years, but one of the things it is most used for is designing objects or remixing existing objects to be printed using a 3D printer. Before we get into the app, let's first come to a basic understanding of 3D printing. 3D printing is also called additive manufacturing, and what this means is that 3D printing manufactures or creates objects by adding material, building it up in layers, as you can see happening in the animation on this slide. A 3D printer works by reading a digital file and interpreting the instructions in that file to create three-dimensional objects using layers and layers of material. The material that 3D printers use is called filament and can be made out of many different kinds of things, including metals, plastics, wood, and more. But polylactic acid, or PLA, is the most common and most beginner-friendly material. The digital files can be created in CAD, or computer-aided design software like Tinkercad, or by taking an existing object and digitizing it, either with an app on your smartphone or hardware specifically designed to create 3D models from physical objects. In addition to these sorts of small consumer-grade 3D printers, there are all sorts of different kinds of 3D printers, including massive printers that can create basic housing structures by layering concrete, which is what's linked in the slide here, a cool video you can check out, as well as medical-grade printers that can create parts needed for surgery out of biological tissues. 3D printing is a great activity to do with your students. It gives them an opportunity to go through the full design process, eventually being able to hold a physical representation of whatever it is they created, which can be extremely fulfilling and motivating. However, there are a few things to keep in mind if you're thinking about 3D printing with your students. The first is time. 3D printing is not a quick process. Even small prints can take up to an hour or more, which adds up with an entire class of students. It's always a good idea to give students size guidelines to keep projects manageable, as well as to have students work in groups so that in the end you have less items to print. Another big consideration is the cost of materials and the potential waste. 3D printing filament is a consumable material, so you or whoever is in charge of the printer will need to purchase more as it runs out. Also, there's always the chance that items may get lost or thrown in the trash. Most of the students we work with are always really excited to print things, but one of our questions is always why. How is this meaningful to you? Does it fulfill a purpose, or are you printing just to print? If printed items are meaningful or useful in some way, students will be less likely to treat them carelessly or just discard them. However, even making sure that students' prints are meaningful, many prints require the use of extra printing material as either a raft, which sits underneath your item to help it stay stuck to the printer until it finishes printing, or as supports that stabilize intricate details or overhangs. For example, the Mario pipe you see in the image on this slide had a supportive structure all the way around it to help that top lip of the pipe print without just falling down. Unfortunately, in most cases, these support structures are just thrown out after printing. So most prints, no matter how meaningful, do create waste, which we're always trying to avoid as much as possible. Having tangible representations of students learning, things that they can see and hold in their hands, can be meaningful. But one question you can ask yourself is, does the item actually need to be printed? For many learning objectives, simply having students design it can be enough. Designs that are created in Tinkercad can also be exported in various formats, which can then be brought into other programs or showcased in a digital design portfolio. The point here is that Tinkercad is an awesome design environment, and the end goal doesn't have to be printing the items that students create. It certainly can be, but it doesn't have to be. So what is Tinkercad? Tinkercad is a beginner-friendly computer-aided design program for creating 3D models that is very popular for schools looking to get started with 3D design and printing. It is a free program and it is web-based, which makes it very easy to access. In addition to creating 3D models, you can also digitally simulate electronics projects with digital versions of Arduino, microbit, and other electronics construction kits, and you can also bring 3D designs to life through block-based coding. Tinkercad has many cool features, including the ability to remix items from the public gallery. So when you create something in Tinkercad, you have the option of allowing others to view and remix or modify a copy of your project. This can be useful for giving your students starters to work with, or when you want to make something, but maybe not from scratch. You can also import items from other programs. So if you find or create a 3D file somewhere else online, you can generally bring it into Tinkercad to view, make changes to it, and so on. Tinkercad gives you the option of collaborating with other users. This isn't something that we'll explore directly today, but you have the ability to generate an invite link that allows others to come and work on your Tinkercad project with you. Finally, you can also export projects from Tinkercad into Minecraft, CoSpaces EDU, or any other project that takes 3D assets. In this session, we are primarily going to be focusing on the three-dimensional design side of Tinkercad, but as I mentioned, there are a few other ways you can use it pictured here. You can use Tinkercad to design and simulate electronics projects, including digital assembly and coding, and you can also use Tinkercad's code blocks to create 3D designs through block-based coding. The coding platform gives you the ability to generate GIFs of your projects as well, which can be a really easy way to track students' progress at a glance. I have some resources linked at the end of this presentation to explore both the electronics and coding sides of Tinkercad, but we are going to focus in on its design platform. One of the reasons that Tinkercad is so popular in the schools that we work with is because of its versatility. It has a full-featured web-based application through its website at tinkercad.com and is also available on the Apple Store as an iPad app. Availability on these different platforms means that most schools in our area can access Tinkercad on either Chromebooks or iPads, depending on what technology the school has. So what are some reasons we might consider using Tinkercad with students? When we're thinking about tools for making or creativity that have been validated for use in the classroom, we ideally like to see direct alignment with educational standards. Tinkercad was awarded the Seal of Alignment for Readiness by the International Society for Technology and Education, often referred to by its acronym ISTE, in 2016. ISTE notes that this resource helps build foundational technology skills needed to support the 2016 ISTE standards for students. To give you an idea, I've documented some of those aligned standards here. For example, ISTE notes that Tinkercad helps students to become empowered learners through understanding the fundamental concepts of technology operations, demonstrating the ability to choose, use, and troubleshoot current technologies, and transferring their knowledge to explore emerging technologies. ISTE also suggests that Tinkercad helps students to be innovative designers, saying that students know and use a deliberate design process for generating ideas, testing theories, creating innovative artifacts, or solving authentic problems. Other ISTE standards that Tinkercad meets, including helping students to become computational thinkers by breaking problems into component parts, extracting key information, and developing descriptive models to understand complex systems or facilitate problem solving. Finally, Tinkercad helps students to be creative communicators by choosing the appropriate platforms and tools for meeting the desired objectives of their creation or communication. Those are only a few of the specific standards ISTE highlights, but the link in the slide here will take you to their website with the full list and documentation. So how is Tinkercad a useful tool for STEAM learning? First, Tinkercad is naturally interdisciplinary. As you're designing, you are thinking mathematically and using fundamental math concepts such as scale and ratio, measurement, geometry, and so on. You're also using artistic skills and concepts, such as design principles and creativity. Students are also learning important transferable technology skills, such as operating in a three-dimensional environment, digital fluency, the impact of technology on society, and more. And because Tinkercad is so accessible for beginners and so focused around the design environment, that leaves lots of room for educators to connect design projects to other subjects, further reinforcing that STEAM approach. For example, to bring in language arts, you might have students create something they read about in a story. To make connections to history, students can create or remix models of historical buildings. And you can design all sorts of science projects in Tinkercad, such as balloon-powered cars, to explore different types of energy. Because it can be hard to start coming up with these kinds of ideas from scratch, I wanted to give you a couple of examples of what STEAM connections can be made with Tinkercad. This is an example of a grade 3 activity using our Ontario curriculum expectations, asking students to design and create a sculpture that could be displayed in a public garden. Looking at the science curriculum, we can address expectations related to designing and building strong and stable structures, and also have conversations about the strength of different materials for this purpose. From an arts perspective, we're asking students to create a three-dimensional work of art that expresses their personal feelings and ideas. We could even add more subjects into this. If we asked students to design their sculpture after a particular historical figure. We could also engage students' understanding of mathematics concepts by giving them size restrictions or asking them to incorporate some kind of pattern into their sculpture. There's lots of opportunities here. Another example is this project drawing on the grade 9 curriculum in Ontario, asking students to model the erosion of riverbeds. Again, drawing on science expectations, students would need to apply an engineering design process to design, build, and test a model. They would also be designing something that explores a problem relevant to STEM-related occupations. This activity also connects nicely to Canadian and World Studies, asking students to explain how human activities can alter ordinary physical processes and contribute to occurrences of natural events and phenomena. Students could model specifically how erosion could be worsened by human activities, resulting in devastating floods and other ecological disasters. And again, you could make connections to the arts curriculum, math, language, and other subjects, depending on how big you wanted this project to be. As we wrap up our introduction here, I wanted to show you some examples of how Tinkercad has been used and showcased by teachers on Twitter. If you want to learn more about these educators, you can click on the images in the slides and it will take you to that Twitter thread where you can read more about the project. The first image here on the left is from The Nerdy Teacher and shows examples of coral reefs that students in grade 5 designed in Tinkercad and had 3D printed. The image on the right is from B. Hurls, who says that their students designed frogs in Tinkercad and then created books about the different ways that frogs adapt to their environments. Just a few more examples here. The tweet on the left is from Michelle Morris, who explains that her grade 3 students remixed a model of Africa to include 3 major geographical features that they were learning about in class. The middle tweet is from the Big Spring School District in Pennsylvania, USA, showing off students' cookie cutters that were again created in Tinkercad and then used to cut out actual cookies. Finally, the tweet on the right is from the STEM coordinator at Ethel McKnight Elementary School in New Jersey, USA, and shares that students were learning about app development and used Tinkercad to design icons for the applications they had made up. So as you can see from these 5 examples alone, there are a ton of different ways to use Tinkercad for STEAM learning. In the next video, we will begin to explore Tinkercad, and you will have an opportunity to work through some activities to begin learning more about the design environment.